So differentiation of trigonometric functions. Okay, so for this part, we're definitely going to need all the identities that were proved when we were reviewing trigonometry. Okay, so I think it would be a great idea if I start by rewriting all the identities here. Okay, if you've seen them, we've seen them together, I know, but I'm going to rewrite them. Okay, so here's a review. So a reminder, let's say, of trigonometric identities. Okay, so it's always repetition, repetition, repetition. Eventually, it's gonna register. Okay, so sine squared x plus cos squared x, we know it's 1. 1 plus tangent squared x equals secant squared x. 1 plus cotangent squared x is equal to cosecant squared x. This we know. Then tangent of x is sine of x over cos of x. Cotangent of x is cos of x over sine of x. Then secant of x is 1 over cos x, and cosecant of x is 1 over sine x. And all this we proved. Okay, I remember we proved all these. Okay, now there's 2 more identities. Okay, which was that the sine of a plus b is equal to, so sine a cos b plus sine b cos a. And then the cosine of a plus b is cos a cos b minus sine a sine b. Okay, so these 2 we did not prove. Okay, I told you it takes some time to prove. It's going to take us 20 minutes to prove. So, and since it's not in the scope of this course, so we'll leave it for now. If you want, if you really want, I could stay after class, I'll show you. Okay, so let's go. The first thing that I'm going to show you is that if f of x, so first thing, if f of x is equal to the sine of x, then how do we do the derivative of that? Anybody know it? What's the derivative of sine x?
1 minus cos x.
What is it?
Minus cos x.
Minus cos x, okay. Anybody else want to try?
1 minus cos x.
1 minus cos x, okay. Another one? Okay, so it's just cos x. Okay, so the derivative of sine x is cos x. Okay, so obviously, so now we have to prove this. Okay, so, I mean, I believe that you have all the tools now to prove it. Okay, because you know what the definition of the derivative is. You know all the identities here. We know also, if you remember, I'm going to add another thing here, is that the limit as x approaches 0 of sine x over x is 1, we showed, and also the limit as x approaches 0 of 1 minus cos x over x is 0. So all this we proved. Okay, so all this is proven besides for these two. Okay, so with all this in front of you, you should be able to prove this using the definition of the derivative. Do you think you would like to try this? Would you like to try it? Yeah, okay.
Yeah.
Yes.
Okay, so let me give you a few minutes. So f of x is sine x. So f of x plus h will be sine of x plus h. This we know. Okay, so we know that f prime of x will be the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, I'm just going to move up a bit, which is equal to limit as h approaches 0 of, so f of x plus h is sine of x plus h minus f of x, which is sine x over h, right? F of x plus h is sine x plus h, f of x is sine x. Okay, now sine of x plus h, okay, so sine of a plus b, same thing, sine of x plus h, so sine x cos h plus sine h cos x. Let me write it down. So it's equal to the limit h approaches 0, so sine x cos h plus sine h cos x, and then minus sine x, and all of this over h. Okay, is this step okay? Okay, and at this point, I'm going to separate into two fractions. So the first fraction will be this one here. So limit h approaches 0 of sine x, sine h, sorry, cos x over h. And then I'm going to go minus limit h approaches 0 of sine x minus sine x cos h over h. Okay, so if you look carefully, this one is a bit trickier because there's a minus. So minus sine x, here he is, and minus minus becomes plus sine x cos h, here he is. And now I'm going to factor out what I can here. Whatever doesn't depend on h, I could pull out.
Can you repeat it, please?
Sure. Repeat this part here.
Yeah.
Okay.
The last step.
The last line. Okay.
Yeah.
The last line, what I'm going to do is the first thing I'm doing is I'm going to decompose this fraction into two fractions. The first fraction is this one. So here he is. That's okay.
Yes.
Yeah. Okay. And then this one and this one, these two terms over h are here. Okay. So sine x cos h minus sine x here over h. I just pull out a minus as well.
Okay.
Okay. So look, if you distribute the minus back in, you'll get minus sine x. Good. And if you distribute the minus back in here, you'll get plus minus minus is plus sine x cos h, just like here.
Okay. Thank you.
Okay. At this point, what I'm going to do is I'm going to pull out whatever does not depend on h. Okay. So here I could take out a cos x because it does not depend on h. So cos of x times the limit h approaches 0 of sine h over h. Minus, and here I can extract a sine x. Sine x times the limit as h approaches 0 of, so 1 minus cos h over h. Questions? Okay, here I could fit everything. So now, well, this limit, it's 1. We see it here. And this limit is 0, we see it here. Okay, so this whole term disappears, this becomes 1, and so my answer, you see, is cos of x. Done. Any questions?
Yeah, can you just repeat the point where you got sine x cos h?
Sin x, sorry, sin x.
The third line, from the third line.
1, 2, here?
Yeah.
Oh, how did I get this here?
Sir. Yes, sir.
Oh, yeah. So this comes from this identity here.
Okay.
Okay, so I'm gonna write it here. So I know that sine of a plus b is sine a cos b plus sine b cos a. Right? This I know. So imagine now if this was an x and this was an h. Okay, so this will be an x, this will be an h, this will be an h, and this will be an x. And you're gonna get this.
Okay, okay. Thank you very much.
Okay. Any other questions? Okay, good. So I think you're ready now to prove the derivative of cosine now. Okay, so we found the derivative of sine, that's the derivative of cosine. So we're going to do the derivative of every trig function now. Okay, and the first two one are the hardest, sine and cosine. The rest you're going to see it's easy. Okay, so I'm going to put this away. And now you're going to try number 2. So if f of x is equal to the cosine of x, then f prime of x will be, anybody know this one?
Is it sine inverse?
What inverse means with the power minus 1?
I believe so.
No, it's going to be sine x, but minus. So it's going to be minus sine x. F of x is cos x. F of x plus h is cos of x plus h. F prime of x, limit h approaches 0. F of x plus h minus f of x over h. Limit h approaches 0. So cos x plus h minus cos of x over h equals limit h approaches 0. And now we're going to use the identity here, which if you remember was cos x cos h minus sine x sine h. Okay, and so I saw some of you forgot this minus cos x here, minus cos x. Okay, don't forget this one over h. Okay. Now, at this point, I'm going to separate again like I did before. So equals to, I'm going to take care of this fraction first. So limit h approaches 0 of negative sine x sine h over h. And then minus limit h approaches 0, so cos of x minus cos x cos h, and all this over h. And now I could extract whatever doesn't have an h. Okay, so negative sine x times the limit h approaches 0 of sine h over h minus, and I'm going to pull out this cos x here. Cos x limit h approaches 0 of 1 minus cos h over h. And now just exactly like before, this is 1, this is 0, so this term disappears, this is 1, and so my answer, I see negative sine of x, done. Are there any questions?
Can you explain how you got the -1 minus cos h over h?
Excuse me, how I got what? Sorry?
How did you get 1 minus cos h over h?
So this step here,
Yes.
oops. Okay, yes, so this step you're okay?
Yeah.
Okay, so I just factor out a cos x. Pull out a cos x, you're left with 1 here and cos h here.
Okay, thank
You see it?
Can you explain again, please?
Yeah. So from this step, there's two terms, cos x and cos x cos h. So cos x is in common, I could extract it. That's what I'm doing. Cos x and cos x, I'm doing a greatest factor. I'm pulling out a factor, factoring it. So the cos x is out. What's left here? 1. What's left here? Cos h.
Okay.
Sure? Okay, you're sure? Or okay, it's too many times and you're
No, it's
afraid
okay.
to ask it again?
No, it's okay.
Okay, good.
So it's like cos x bracket 1 minus cos h close bracket.
Excuse me? Yeah, exactly. Exactly.
Okay.
And the cos x, I just pulled it outside of the limit because it does not depend on h. So it has nothing to do inside. I could just pull it out. It's useless there. It's like a
Why
number.
do you have a minus cos x cos h if the third equation is cos x cos h?
I'm sorry, I didn't understand. If what? If?
Why do you have a minus cos x cos h?
Oh, this one here?
Yeah.
Because I pull out a minus here. You're
Okay,
right.
so minus,
It's a
minus,
plus
plus.
here, right? It's because of this
Yeah.
plus. Okay, so minus times minus is plus.
Okay. Okay.
Good. Okay, don't let anything slip through your fingers. Okay, it's good what you're doing. Every minus, ask why is it there. It's very good. Okay, questions?
Yeah. After pulling out the cos x, where does it go after that?
This cos x?
Yeah.
Well, this is going to be 0. So cos x times 0 is 0.
Okay. Thank you.
Okay, good. Okay, number 3, let's do the tangent now. Okay, so the tangent, I'm going to do it myself because we're going to do it differently. So if f of x is equal to the tangent of x, then f prime of x, anybody know this one?
Minus sec x.
No, it's going to be secant squared of x. Okay, so if you don't know it, you can't guess it really. Okay, let's prove this. Okay, so I'm going to prove the tangent is secant squared, and then you're going to prove the cotangent squared. The cotangent. Okay, so let's go. So f of x is equal to tangent. But tangent, we know it's sine over cos. Okay, this we know. All right, so f prime. So I could use now the quotient rule, right? Because it's a division to find the derivative. So derivative of top times the bottom minus the top times the derivative of the bottom, and all this divided by the bottom squared. Right? This is the regular quotient rule, which we've seen last class, I think, or 2 classes ago. Who's got questions on what I just did here? Okay, so again, first thing I did, I noticed that tangent is sine over cos. Since it's a division, I have to derive this. I'm going to use the quotient rule. And that's what happens. And now this is good because I just showed that the derivative of sine, I know it's cos. The derivative of cos, I know it's minus sine. So I could now replace everything. Okay? So this is cos x minus sine x times, this is the derivative of cos is, we said, minus sine. And divided by cos of x squared. Very good. I don't need to go to the derivative now. No more limits. Okay, so I just use the limit definition to show the sine and the cosine. The rest, I could use that fact. Okay, so what do we have on top now? So cos squared. And then minus plus sine squared over cosine x squared. Okay, cos squared plus sine squared is what?
1.
That's 1. So this is 1 over cos squared x. And 1 over cos is 1 over cos, I think it's secant. So 1 over cos squared will be secant squared x. There you go. I just showed it. Okay, you get it? Okay, so let's try number 4. F of x is equal to cotangent of x. So f prime of x is equal to, this is going to be negative cosecant squared of x. Sorry.
So you're still muted.
Sorry, I was muted. You're right. Thanks. Okay, so f of x is cotangent x equals cos x over sin x. And now I'm going to derive, I'm going to use the quotient rule again. So derivative of top times bottom minus top times derivative of bottom over bottom squared. Okay, so derivative of the top times the bottom minus the top times derivative of the bottom. There we go. Okay, so 2 little derivatives to find and know them. This is negative sine x times sine x minus cos x times cos x of this over sine squared x. And then I can extract the minus here on the top. So I'm going to extract the minus, and this becomes sine squared x plus, and this will become cos squared x over sine squared x. The top is 1, so I have negative 1 over sine squared x. Okay, and then this is equal to, so 1 over sine is cosecant, so this will be negative cosecant x, negative cosecant squared x. Done. Okay, are there any questions? Great. Okay, 2 more. Number 5. F of x, so is secant of x. Then what is the derivative of secant of x? Well, it would be secant of x times tangent of x. F of x is secant x, which is equal to 1 over cos x. Okay, so to do the derivative, so I have 2 choices. I could either do the quotient rule, okay, or I could do the chain rule. Okay, I'm going to do both because it's a good exercise. Okay, so I'm going to first do the quotient rule because I'm sure that's what you all did. Okay, so I'm going to do it here. F prime of x will be, so derivative of top times bottom minus top times derivative of bottom over the bottom squared. Okay, so this is prime and this is prime. And so I get 0 times cos x minus 1 times minus sine x over cos squared x. And this, of course, is 0. And so I have minus 1 times minus sine x over cos squared x. And that I could split into sine x over cos x times 1 over cos x. And that is tangent and that is secant. Okay, so secant x times tangent x, that's very good. Okay, easy. So this is using the quotient rule. So let's say I wanted to use the chain rule. Okay, so I'm going to do it here. Separate the page in 2. Do it on this side. Okay, so this is also equal to cos of x to the power of minus 1. Right? That's what 1 over cos x is, cos of x to the power of minus 1. Okay, so f prime of x, how do we derive this? So we've seen power rule, so you put the minus 1 in front. So minus cos x to the minus 1 is minus 2 times the derivative of the inside. Okay, you understand this? This is the chain. And so I have negative cos x to the minus 2 times the derivative of cos, which is negative sine x. And that's it. Minus times minus is sine x. And then cos to the minus 2, so over cos squared x. And I'm back to what I had here. Same thing. Okay, that's it. Same argument. Sine x over cos x times 1 over cos x, which is again secant x times tangent x. So another way to do it. So this one using the quotient rule, this one using the chain rule. All right, any questions? Okay, so let's do now the derivative of cosecant.
So, sir,
Yeah.
I have to know the both ways to solve this question.
Well, you have to be comfortable, whatever way you like.
Oh, okay.
Okay. Number 6, and the last one. So if f of x is equal to cosecant x, what's f prime?
Minus cotan multiplied by cosecant.
Very good. So negative cosecant x times cotangent x. So this is the derivative, and let's prove it. So f of x is equal to cosecant x, which is 1 over sine x. Okay, so again, I could do it both ways, either using the quotient rule or using the chain rule, whatever you prefer. Okay, I personally prefer the chain rule, but it's up to you guys. Okay, I'll do the chain rule here. So sine x, this is sine x to the minus 1. Okay, so f prime of x is equal to the derivative is minus 1 times sine x to the minus 2 times the derivative of sine x. And so that is minus 1 times sine x to the minus 2 times the derivative of sine, which is cos x. And that is negative cos x over sine squared x. Okay, that's okay for you guys? Okay.
Yes.
And then I'm gonna separate it. So negative, so I'll do 1 over sine x times cos x over sine x. And that is negative cosecant times cotangent. And that's what I need to prove. Done. Okay, any questions?